Alright, this is maybe 12. Right, it's asking you to evaluate that using table. Um, if you already know how to do this without a table, that's even better. So I'm going to just use the U substitution here. If you extend, what is my do?
So this
So I got to check.
10 is extra, so I gotta take 10 away.
So what do I have?
So what do I have?
I have EU, DU, which
DU,
is
which is
E
EU plus C, but this is definite limits
from 0.
from 1 to 0.
We started with
We started with
X,
X,
so back
so
substitute.
back substitute.
Plug in 1,
Plug in 1,
I get E.
I get E to be 1.
Plug in 0, get
Plug in 0, I get
1.
1.
C.
A, B, C, D, or E. C.
Not much about
13, I'm
it,
not
but
going to
you
talk
gotta
much
look it up
about
on
it.
the table, and the answer for 13 is B.
13 is B. Go to 14.
Is
14
evaluate.
evaluate limit x
Okay.
goes to infinity. 56 minus 7x plus 8x squared divided by 5x squared minus 7. Okay, it asks you to do it two different ways. First by using techniques from chapter 3 and then using L'Hopital's rule. Okay. Alright. So, is there a way we can factor this out?
No, before.
So using what we could know before from algebra. If I go ahead and line them up like this. Okay.
And
And then
the
divide both numerator and denominator by
highest
the highest exponent. So the highest exponent is x squared.
square.
So divide everything by x squared on the numerator and denominator. Alright, let me see what we have left. We have now if you put in
This
x equals infinity, this will be 0, this will be 0, this will be 0. We get 8/5. So this is doing it the way we know. Now using L'Hopital's rule. Okay. So second way. The question is, do you have to know both ways? Yes. So L'Hopital's rule is take derivative from numerator and denominator. If I take derivative of that, I get
Take derivative.
so I took derivative. Now if I plug in infinity, still we get undefined, so I get take derivative again.
What is it?
Take derivative again, I get 16 over 10. Because the x disappears, and now if I put an x as infinity, it really doesn't matter.
16 over 10.
16 over 10, isn't that 8/5 anyways? Same answer as before in part A.
Twice.
Go to the next one. Evaluate using L'Hopital's rule. This is number 15. And the choice for 14 is choice B. Alright, so can we factor this out? Is there any way we can do this where this could be reduced? No, we're gonna go ahead and just go ahead and take derivative. If I take derivative, I get 2. Get 8x plus 8. Okay, so now can we plug in infinity and not get undefined? Yeah, if we plug in infinity, what will we get? Would get 2 over infinity. 8 times infinity is infinity plus 8 will be still infinity. 2 over infinity would be 0. Okay, that'll be choice E. These are short, nice problems. Okay, look at 16. Evaluate the limit.
Okay.
Okay, so to do this one,
We'll
we will go ahead and split this up and make this
so
so where did I get this from? If you remember from Cal 1, we tried to make it a rational
That's 1.
function, right? And anyone remember what that goes to?
Right.
That's
8
1,
over.
right? But that's not the reason we do this. We'll do this because so we can use L'Hopital's rule. Now, if I have 8 over x
In the side.
in the denominator, what would I have to have on the numerator? Well, remember,
Flip this
if
to
I
keep.
flip this one, it'd be x over 8. So the x came from here, right? And I don't have an 8, so I made up that 8. So I gotta have 7 times 8 here
The balance.
to keep the balance. So this one becomes Now, what can we do?
We can
Well,
and
we can go ahead
plug in.
plug in
Go ahead.
infinity, and if I plug in infinity, this is 8 over infinity or 0. This is 8 over infinity or 0. We cannot divide by 0. So
Just
we
go
have to go ahead use L'Hopital's rule and go ahead take derivative.
X.
And we can just go ahead leave the 56 there. What's the derivative of sine 8 over x?
8 over x.
Cosine 8 over x. And then you have to take derivative of 8 over x. What's the derivative of 8 over x? Negative 8 over x squared, by chain rule. That will be the same thing here. And those two, including negative, will cancel out. Now we can bring the 56 out because it's a constant. Now we have
X.
8 over x. Now if we plug in infinity, we get 8 over infinity of 0. What is cosine of 0? 1. That's 56. That which was B. Alright, we did 16, now let's go to 17.
No x.
17 is goes to 8 from the positive side. And says evaluate the limit, use L'Hopital's rule if needed. Okay, so let's go ahead and put those two together. By finding the common denominator.
Minus 8.
You know, x minus 8 times x plus 8 will give you that. So that means what we're going to multiply here by. Alright, so let me combine some like terms here. Positive 21, take away negative 8.
No.
What is that? Positive 13. Can I take out a negative here for ease of factoring out? We can factor this out as what? Eight and 5. Negative, negative. Right? Or, if we wanted to, we could have actually taken the derivative here instead of factoring out here. Okay? So I'm doing both ways here. So from here, I factor it out. So this is the old way. So who remembers what we do next? Well, let's plug in 8. And I believe this is D. Now you could have picked it up here and used L'Hopital's rule. So this is the second way. And actually it's less work. So if I took derivative, right? Now can we plug in 8? That's negative 16 plus 13. That's 16 minus 64. I'm sorry. You right? Oh, this is 0. That's what it is. Okay. So this is still it's a little bit faster than this one. Same. Yeah. So choice is still B. Let's go to 18. Is infinity to 0 x e to the negative x over 3 dx. Okay? So the question is determine whether the improper integral diverges.
Alright, so you see this improper integral? You can make it limit bigger than infinity and v to
0 x
negative something. That's
3 over x dx. So
something we
that's something we can do.
so this part that
So
part
this part is going to be integration by parts.
dx.
So du will be dx, and if we take integration of e to the negative 3 over x, what do we get? V is negative 3 e to the negative 3x.
Okay. So now you
So now uv minus v du. So we could actually write this as
that's definitely
what? What can we write this as? Well, if we took out e to the negative 3 over x, negative 3x minus 9. Now remember, this has definite limits. We change it to b to 0, so we're gonna plug in okay, and then we have the limit always. let's plug in b and 0. So tell me, what do I get? Well, if I plug in b, don't I get e to the negative b over negative 3 over b, right? Times negative 3b minus 9, and then minus, if I plug in 0, I get e to the 0 or 1 minus 9, right? So now if I put an infinity, this becomes what? Well, this becomes 3 over infinity, or 3 over infinity is 0, so that's 1, right? And then this is 3 times b minus 9, so what does that become? That one just goes away, 0. Because if you look at this function right here, that if you take out e to the negative 3 over b, that is 0, right? Okay, so what survives is negative times negative is positive 9, and that is choice A. Yeah, choice A. So make sure you understand what's going on here, and review, ask me questions. Let's go to 19. 19 is determine if this converges or diverges. So we know we have infinite discontinuity where? Right? So we can do this. Zero.
What's the integration?
What's the integration of dx over x? Right? So this one is 0. So I have okay. So what is ln of 0? Well, if you think of the domain of ln, what does that indicate? What does it indicate is going to be? It's going to go to, it's going to diverge, right? So think about why it diverges. Graph it and see. If you still don't understand, let me know. Okay. Alright, that brings us to the last problem, the sample test, number 20.
Chapter
20 looks like we have to find the area of this. It's like this. Area under the curve. Now if you split them up, it is symmetric. So this is the type of problems you have to split this up. Alright. So we know we're going to go from negative 3 to positive 3. Okay? And by theorem in your book,
go from
page 568, definition 3. So when we have something we can split up, then we can write it as two different integration, right? So we could write this one as, well, we know we
to
can
negative
go from
three.
to negative 3, but since it's symmetric, we're going to break it up as 0 to negative 3, as 3 to 0. Alright, so what's the integration of 1 over x squared plus 1? You remember that? That arctan? Yeah. So this is going to be 2 arctan x plus 2 arctan x, and this one's gonna be 0 to negative 3, this one's gonna be 3 to 0. Take out the 2, and you're gonna actually get arctan of 0 to negative 3, and 3 to 0 will actually give you, okay, so check and verify this one. Okay, so that's the last problem, so the choice would be A. So remember, this one I'm not giving you written solution, you have to watch the video to get the solution. If you still have questions,